All thought and action result from your nervous system, the brain, spinal cord, and nerves. This system is more sophisticated than any computer.
You still think a human can beat a machine? You better believe it.
Hey, you bring your sorry circuits onto my turf and think you can bring me down. That's whack.
That's not our best move.
Queen 2, knight 2, queen 2, knight 2, queen 2, knight 2.
It's 3 pounds of tissue, controlling everything we do. Our brain works faster than any computer, processing an astounding 100 trillion instructions every second.
Wow. The human brain. I hold in my hands the pinnacle of God's creation.
Somebody check my brain. Neocortex, frontal lobe,
Brainstem!
hippocampus, neural node, right hemisphere, pons and cortex, visual,
Brainstem!
Sylvian Fisher, pineal, left hemisphere, cerebellum left, cerebellum right, synapse, hypothalamus, striatum, dendrite. Axon fibers, matter gray,
Brainstem!
central tegmental pathway, temporal lobe, white core matter, forebrain skull,
Brainstem!
central fissure, cord spinal, parietal, diameter, meningeal vein, medulla oblongata, and lobe limbic, microelectrodes, the brain. As soon as it falls into my waiting arms, I will have the power.
All that's missing is the brain. Dizzy-Gord, give me the brain.
Oh, just ask him.
Sorry, did you just say you need my brain?
Yes.
Yes! You can't have my brain. I'm using it.
What's on your mind?
Precisely. What's on all our minds? Brain waves.
The human brain emits certain electromagnetic waves, called brain waves, according to a person's activity and relative circumstances. Brain waves are divided into gamma waves, beta waves, alpha waves, theta waves, and delta waves.
These waves fluctuate with the perceptions of our minds and dictate reactions within our bodies.
The trillions of neural networks, like an improvisational orchestra, create new ideas.
This is accomplished in 2 ways, within the neuron itself and between neurons. A typical neuron is composed of a cell body, dendrites, and axons. The dendrites carry impulses towards the cell body. The axons transmit them away from the cell body. The contact between one neuron's axon and another neuron's dendrites is called a synapse.
Check out the synaptic cleft, with thanks to vesicular trafficking, a neuronal signal can be transmitted from electrical to chemical and back again.
The cell membrane of a neuron encloses cytoplasm with various ions dissolved in it. The neuron itself is immersed in a salt solution, the extracellular fluid. The ions of the cytoplasm consist mainly of positively charged potassium ions and large negatively charged organic molecules, such as proteins. Outside the cell, the extracellular fluid contains mostly positively charged sodium ions and negatively charged chloride ions. Since charged particles cannot pass through the lipids that make up cell membranes, they must travel through channel proteins that extend through the membrane. In an unstimulated neuron, only potassium ions can cross the membrane, traveling through specific proteins called potassium channels. Although sodium channels are also present, in unstimulated neurons, they remain closed.
Passive transport works by diffusion. That's the natural spreading of particles through a liquid or gas. Particles move from areas of high concentration to areas of lower concentration.
Since only potassium ions can cross the membrane, and potassium ions are more concentrated inside the cell, they diffuse out of the cell, leaving the large negatively charged organic ions behind. As more and more positively charged potassium ions leave, the inside of the cell becomes increasingly negative. But since opposite charges attract, as potassium ions diffuse out, an electrical force develops that tends to pull them back inside. At some point, the diffusion of potassium ions out of the neuron due to concentration differences is balanced by the electrical attraction tending to pull them back inside. This is the point at which neurons reach resting potential. This potential, called resting potential, is always negative inside the cell. But it is action potentials, not resting potentials, that carry information through a nervous system. The negative potential inside the neuron can be made either more or less negative depending on the stimulus. If potential is made sufficiently less negative, it reaches a level called threshold, and an action potential is triggered. During the action potential, the neuron suddenly becomes 20 to 50 millivolts positive inside. Action potentials last a few milliseconds.
At a chemical synapse, a neurotransmitter molecule, such as acetylcholine, communicates a signal from one neuron, the presynaptic cell, to another, the postsynaptic cell. Neurotransmitter molecules are stored in vesicles in the presynaptic neuron. Some vesicles dock, via specific docking proteins, at the presynaptic terminal. An electric impulse, called an action potential, arrives at the synaptic terminal, and docked vesicles fuse with the presynaptic membrane, dumping neurotransmitter into the synaptic cleft.
Substances that need to be released are enclosed in a vesicle, which fuses with the cell membrane. And then whatever's inside the vesicle gets released outside the cell.
Neurotransmitter binds receptors on the postsynaptic cell, which, depending on the specific receptor and cell type, open or close ion channels. Thus, the action potential passes to the new cell. The empty vesicles are recycled via endocytosis of clathrin-coated pits and take up more neurotransmitter to start the cycle again.
This is cell membrane.
Here we can see the cell off in the distance. The cell membrane surrounds it.
Against the grain, that's where I'll stay. Swimming upstream, I maintain against the grain.
Faster, stronger.
That's beer. Bottoms up. Now you. Look. Blue? Just past the brewski, bub. Hey, don't be such a hog. Bunch of hoity-toity goody-goodies. That's ridiculous. I don't know how to drive. This is more like it. That's not a very good sign. Evils of alcohol. Drinking's uncool.
Use your brain. Don't drink alcohol or take drugs.
What smells? You babes wanna hang? Or what? Farfarama, they've been drinking.
Somebody check my brain. Check my brain.
Es ist ein Leichnam und keine Puppe. Wie bewegt sich ein Körper? Muskelkontraktion ausgelöst durch Nervenimpulse. Funktionieren Nerven. Elektrische Impulse. Und Impulse sind machbar. Man braucht sich nur an ein Starkstromkabel zu hängen. Wenn man doof ist wie Sau, dann kriegt man aber